Hello, students. Math connection time out of 6.2. 6.2 has 1, 7, and then 10 through 15. So notice the first question is very similar to what we talked about in previous portions. If you take 1/3 and you add 1/4, but it's 1/3 of a large pizza and 1/4 of a small pizza, does that represent the amount that you actually receive? That's the concept. Should I use 1/3 plus 1/4 to represent that amount? Okay. Explain why or why not. Very common question for students to think 1/3 plus 1/4 would be the perfect way to represent that, but maybe not. Whew. Which of these hold true for subtraction of rational numbers? Again, totally up to you, but think about how that would actually come through. Lastly, if you are computing with whole numbers, that might not be a bad one to try as number 6 as well. And what else do we have? Oh, that's the Egyptian unit fraction piece, but I didn't assign that one. Let's hear 10. Question 10. So here we go. 1/3 plus 3/4 gets you 4/7. You can demonstrate it. There it is. Anything wrong with that? Anything right with that? Does this make you think of something from maybe 6.1? Kool-Aid. Totally up to you if you see something. To show 2 3/4 is 11/4. They drew this picture. And Ken says, this looks like 11/12, not 11/4. Is Ken on the right track? Does he have a good point? Is the teacher on? Could they both be right? Could they both be wrong? That's what we're looking at. How would you respond? A student claims for positive fractions, if you have the same numerator and you add, then getting the result would be to keep the numerator the same and add those denominators. Now, before you say no to that, you might want to check it out and see if that actually does work. If it doesn't work, have some counterexamples. Okay? We can see why the student might think that, because when the denominators were the same, we just added the numerators. So if the numerators are the same, maybe you could see where Jill's coming from. She's making good connections. She's being logical. She's not just making something up. Okay, let's see here. Explain the error pattern on John's test. So again, you need to think of A, B, and C as being different questions and thinking about what John is doing. So your goal with an error pattern is seeing what is the student doing incorrectly. Can I pick it up so that I can understand why they're getting these wrong? And unfortunately, there are times where the student might get something correct by doing it incorrectly. So that's the goal of finding error patterns. And let's see, we've got Kendra again. I think Kendra's name has appeared a couple times in here. Kendra drew the picture to show 3 2/3 equals 5/6. Got it. Okay. So how can you help her if you're struggling? So what you can see is here's a whole box, that's 1. Here's a whole box, that's 2. Here's a whole box, that's 3. And then for the next component, what she did is she said, well, I don't want that. I want 2/3. So she made a box that represents 2/3 of a shape. Then she put those together. And when you slide them all together, you get 5/6. Okay. Is she on the right track? Are there parts of it that are correct and something else that's incorrect, or is everything correct? Maybe she's perfectly fine and you can demonstrate that. Allie claims if you add 1 to the numerator and the denominator of a fraction, it's the same as adding 1 to the original fraction. How can you help? Is she correct? Is she correct sometimes? What is she finding if she adds 1 to the numerator and the denominator of a fraction? Maybe, is it ever the same as what she started with? Could it be different? Is it bigger? Is it smaller? Kind of help Allie investigate this so she understands that a little bit better. We're definitely getting into some pieces that for some of you might be more complicated. Perhaps you are like some of these students, you struggled with fractions, or maybe you still do. But it's time to kind of get over that frustration, get over that fear, and conquer this. So please don't think that if you're not good at fractions that you should avoid them. If you're not good at fractions, you need to actually do even more fractions. So, all right, hopefully that's helpful. I'll see you soon. Off you go.